Welcome to the THORChain Whitepaper walkthrough. So, starting with the abstract, THORChain aims to make it possible to trade digital assets without a central organizing company at fair market prices in a way that's resistant to attack. The network is made up of anonymous people running nodes, and nodes are basically computers which run the THORChain software. These nodes are regularly kicked off the network in a process called cycling, and this is done to make sure that of a few things. One, that trading is always available, that's the service that the network provides. Two, that no individuals gain control over the entire network. And thirdly, that the system can improve over time. Together, nodes create addresses to hold assets like Bitcoin, like Ether, and many more. Nodes will watch these addresses, and when assets are sent into them, nodes record these events on the THORChain blockchain. When assets are coming into the network, all nodes need to be involved. On the other hand, when assets are going out, much smaller groups of nodes are used. This is more efficient and quicker. This smaller group of nodes decides together whether or not to approve a transaction out of the network. Many processes on the network are mediated by the network's token, which is called Rune. To secure itself, the network aims to have 67% of Rune bonded by nodes and 33% of it staked by liquidity providers. In general, THORChain is designed to have as little formal governance as possible. Important decisions like which assets to list are made by liquidity providers staking capital. Introduction. There are a lot of crypto assets out there now, but it's never been possible to exchange them all in a decentralized way. Instead, what you need to do is you need to use centralized exchanges. Centralized exchanges are companies which need to take hold of your assets in order for you to exchange them. So thus far, there hasn't been a way to do this in a way that's native to crypto. That is, where no individual entity is taking control of your assets. A network like this would allow anybody to contribute to its security and available assets. As more people get involved, that network would become more secure. A network which solves this problem should be able to connect to any chain, firstly, should also be able to connect to as many chains as there's demand for. What's more is it should be available for anyone to use and anybody to contribute to. And lastly, it should be strong and resilient, always staying online and not falling under the control of a small group of individuals. So to give an overview of the network, basically THORChain is managed by a large group of nodes. To participate in the network, nodes need to put up money. This is what's known as a bond, and it makes sure that nodes have skin in the game. They're only selected if they've put up enough capital. Nodes watch for transactions into the network from external networks like Bitcoin, Ethereum, and potentially infinite others. Then the nodes follow a process to come to confirm which transactions took place. Once they've come to agreement, they can take further action. Nodes are also involved with approving assets to be sent out of the network. Small groups of nodes come to agreement using a process called the threshold signature scheme, TSS, and that's something that we'll talk more about later. This process, TSS, makes sure that all nodes agree on when to send assets and how much to send. So let's talk a little bit about nodes, and firstly, how bonding works, how they bond into the system. So anyone can apply to become a node. All they have to do is send Rune into THORChain's primary vault, and this is known as bonding. If they bond enough Rune and are picked at random, then they enter a competition with a few other nodes. If they're successful in the competition, they become an active node on the network. Nodes are regularly cycled, which is something we talked a little bit about earlier, and it's a regular feature of the network, and something I personally find very interesting and very exciting. Cycling means that every few days a random set of nodes are kicked off the network. At the same time, several new nodes are brought into the network through the process described just a moment ago, where they apply and go through competition. This cycling makes sure the service of exchanging assets is always available to users, and it stops a small minority of people getting control of the network. So In terms of servicing the network, nodes can't participate in governance. That is, they can't change the rules of the system. What's more, they can't decide which transactions can be made or which assets are supported. They don't have any opinion on that. They can't have an opinion on that. So to make sure of this, nodes are kept anonymous on the network. There's no formal way for one node to talk to another or to know who is behind another node. So nodes can actually be punished on the one hand. So they can be punished for not properly recording transactions they see on connected chains. They can be punished for not committing blocks, and they can also be punished if they disrupt the approval process for outgoing transactions. On the flip side, obviously, nodes need to earn rewards in order to be incentivized to participate on the network, and they do earn rewards every block, and they can claim them whenever they leave the network. To leave the network, nodes obviously they're kicked off regularly in the cycling process, which I described earlier, but they can also request to leave the network at any time, and that process takes a few hours. When nodes leave, they get back their initial bond plus any rewards they've earned. Once nodes have left, they can rejoin at any point by bonding in again through the process that I described a moment ago. In order to rejoin the network, nodes need to rebuild their node software. This encourages them to be running up-to-date software at all times, and in practice it makes sure that the network stays up to date as time goes on. Next, let's talk a little bit about how THORChain connects with other chains. The first thing to talk about is one-way stake pegs. So THORChain connects to networks like Bitcoin and other external networks through what's known as one-way stake pegs. And this means that no assets are pegged as you see in other comparable projects, only the state of transactions on the external network are synced into THORChain. Specifically, the system keeps track of how much of the asset was moved on an external network, associated information like the ID of the transaction, the address of the sender, as well as the address of the person receiving the asset. Note that only information about transactions involving THORChain are synced. Not every transaction on the external network, so THORChain isn't syncing the entirety of the Bitcoin network into itself. It's only syncing transactions which relate to THORChain. In order to make these connected chains possible, code needs to be written on a chain-by-chain basis. So in keeping track of what's going on other networks, nodes need to watch what's going on. So when a node sees a transaction on a connected network, it records this in what's called a witness transaction. A witness transaction is, in essence, a message from a node saying, this is what I saw happen. So it might be, I saw somebody send one Bitcoin into THORChain, for example. And nodes are watching connected chains all the time and sending witness transactions into the network on a continuous basis. So witness transactions have a standard structure, it's worth noting, no matter which network they came from. So for example, a Bitcoin transaction looks very different to a Binance chain transaction, but in THORChain they have a standard, similar, same structure, so that they would look exactly the same. As these witness transactions come into the network needs to process them and decide which ones are correct. So nodes might make mistakes or disagree about what is happening in the external networks. In order to reach agreement about a specific transaction ID, one transaction on an external network, the network looks at all the witness transactions which relate to it, i.e. all of the witness transactions with that transaction ID. When the network sees that 67%, what's called a supermajority of nodes, agree on a transaction, it's approved and considered correct. Nodes are punished, it's worth noting, if they miss witness transactions. And they're also punished if they get a transaction wrong. So for example, if more than 67% of nodes say this transaction was for 1 Bitcoin, but you as a node say it was for 1.5 Bitcoin, you'll be punished. So in practice, the punishment works like this. If you make a mistake as a node, you receive a slash point, and that's marked against your name, your address. When you leave the network, either as the network cycles you out, or as you choose to leave, you will lose rewards based on the number of slash points you've got. So another thing which is worth talking about is that the fact that blockchains can be messy. Sometimes they'll record a set of transactions, but will change them further down the road. And this can happen because of things like double spending, chain reorganizations, network forks, etc., etc. THORChain needs to have a way to handle this because it needs an accurate record of what's going on those chains. So to combat this problem, all nodes keep their own copy of transactions of each external chain, and this allows them to update according to what they see on those external chains. Next, let's talk a little bit about liquidity and how the liquidity works on THORChain. So THORChain uses something called uses a model called the continuous liquidity pools, or CLPs. THORChain keeps pools of assets. These pools contain an external asset and Rune. This means that at any given time, all external assets are linked via Rune. This makes it possible for the network to know the price of any external asset at any given moment. It also makes it possible for users to move directly from one external asset to another. For example, from Bitcoins to Ether or Binance Coin to Monero. It's helpful to think of pools as being in one container, but in reality, pools are spread across lots and lots of different addresses. They're, in essence, virtual. This is important for security. The system keeps track of all the different addresses, which enables a user to consider a pool as a single entity. This whole design, known as CLP, allows liquidity to be tied to security. So as more value is pooled on the network, the value of Rune grows and the network becomes more secure. It also allows THORChain to subsidize the cost of moving external assets out of pools. So in terms of providing liquidity providers make special transactions to deposit assets into THORChain vaults. The network tracks how much you put in and what proportion of the pool you own. So there's a formula to working out how much of a pool you own, and that's something that we'll cover in later parts of the Rebase coverage of THORChain. But suffice to say that you can find it in the whitepaper, you can find it on the Rebase website, and I encourage you to take a look and play around with that formula. Liquidity providers make another special transaction, so they make a special transaction to deposit assets, and they have to make a special transaction also to remove their assets from the pool. They then get back the initial assets they put in, and as well as the fees they earned whilst providing liquidity. So that's providing liquidity. In terms of exchanging assets, users as opposed to liquidity providers, so users are people who want to swap assets, either traders or whoever, they also need to make a special transaction into the network. And that transaction says which asset they want, where they want to receive that asset, and what price they want to buy the asset at. Again, there's a special formula which is used for calculating the asset exchange. That's something that we will cover in more detail later on, again as our coverage of THORChain, but you can for now take a look at it in the white paper notes we've got here on the Rebase website or on the white paper itself. So this formula is based on the constant product automatic market maker formula, same as you've probably seen Uniswap use, but the formula is more evolved than that, and additionally has a slip-based fee. So users are charged fees when they trade assets and when they take external assets out of the pool. The trading fee is based on how much your trade causes the price between two assets to fall, which is known as the slip-based fee I mentioned a moment ago. This makes sure that the fee goes up and down according to demand. So it ties the fee to the amount of demand, which makes sense. It also encourages buyers and sellers to take into account the effect of the speed of the trade on price. So if you want to push a trade through quickly, you'll pay more. Again, I think that makes sense. In addition to the trading fee, there's a network fee, and this is charged when you take assets out of a pool. The fee is used to pay for gas costs on external networks, and it's based on the external network's average cost of gas. So THORChain manages several vaults, and these hold assets for a number of things. Firstly, the liquidity pools, the node bonds, so the bonds which nodes make in order to participate in the network, and as well as reserves, so backup reserves. Vaults are non-custodial. All outgoing transactions are handled by the system and are only ever initiated by the asset's owner. So THORChain has no ownership over the assets in its system. Individual nodes never hold the key to withdraw funds, and so they cannot get access to funds on the network. Vaults are managed by the threshold signature scheme, which we mentioned earlier, and the threshold signature scheme requires a supermajority, which is 67% of nodes participating in that approval process, known as a key signing ceremony, to approve vaults to leave a vault, approve funds to leave a vault, rather. Every time the nodes are cycled, which happens every few days, the vaults are recreated and assets are moved between them. This is a security measure, and so each connected chain has one primary vault to keep incoming assets and multiple secondary vaults for sending assets out. Each node is involved with every primary vault and some secondary vaults. To send assets into a THORChain pool, liquidity providers first need to get the current primary vault address for that connected chain. This is potentially an attack vector. It's a potential vulnerability of the system in that essentially somebody could send you a fake address. So when liquidity providers are trying to enter the system, they ask multiple different nodes for information about what the vault address is, just to get an average and be sure that they're sending it to the right place. When the assets have been sent, the nodes see them enter their primary vault address, and they create witness transactions and send them into the network, as described earlier. When assets need to be sent out to, for example, return a bond, or for a withdrawal, or for an exchange, the network picks one secondary vault to do that. The process of approving an outgoing transaction, like returning a bond or for a withdrawal or for an exchange, is much faster than incoming transactions. And this is because fewer nodes are involved with that approval process. If the nodes taking care of the secondary vault don't process the transaction, they get punished using slash points, and they're punished according to the size of the transaction value. So the bigger the transaction, the bigger the punishment. If this failure does happen, the primary vault takes over the processing. When preparing to make an outgoing transaction, the network will look for secondary vaults that have enough assets. It will do a scan and find which are suitably, which secondary vaults have enough assets. To make sure that secondary vaults have enough assets on a regular basis, the network will top them up from primary vaults. And so in general, half of the vaults for a pool are kept in the primary vault and half of them are kept in secondary vaults. That's the split which the network aims for. Primary vaults are reconstructed every few days during the node cycling process. It can also happen more often, for example, if a node wants to leave. Secondary vaults are also cycled whenever a node leaves the network, and this makes sure that vaults always have enough active nodes to be secure. So now it makes sense to talk a little bit about the threshold signature scheme, TSS. Threshold signature scheme design was first introduced in a paper by Gennaro and Goldfeder in 2018, and TSS makes it possible for groups of nodes to approve transactions together more efficiently. It's used in two parts of the system: key generation and key signing. Key generation is basically creating vaults, and key signing is approving outgoing transactions. Key generation occurs when groups of nodes create a new primary vault. Through TSS, the nodes create a public key together, and all secondary vaults for this connected chain are based on this public key. This key generation process supports chains like Ethereum, Polkadot, a bunch of different ones based on different curves. Key signing, on the other hand, occurs when nodes need to approve an outgoing transaction from a secondary vault. The transaction is first given to a particular vault to approve. The nodes looking after that vault get ready to sign off on the transaction, and when there are enough nodes ready, the sign-off begins. Once signed off, all nodes try to broadcast to the connected network, and one of those is accepted. In order to make this happen, code needs to be in place to translate this outgoing message from THORChain, the THORChain format, to that of the external chain. In key generation, each node checks that the other nodes haven't done anything wrong, and the system also makes sure that nodes don't cheat using something called a commit reveal scheme. This makes sure that nodes can't cheat the system by saying one thing, having it accepted, and then quickly changing it to their benefit. In key signing, cheating is prevented because nodes only sign messages that are off the network. There are three main points in the system where nodes come to consensus, and it's important to understand this because these are these represent the basic assumptions of network security on THORChain. So the first point in the system where nodes need to come to consensus is where transactions are about transactions happening on connected chains. The second is how these transactions are structured on the network's blockchain, on the THORChain blockchain. And thirdly, they need to come to consensus about when to send money from secondary vaults out of the network. In all three cases, a supermajority of 67% is needed. This prevents Sybil attacks where one person or group takes control of multiple nodes. It prevents these attacks by requiring that nodes bond Rune. And Rune obviously needs to be acquired on the open market, so for an individual to gain a supermajority becomes extremely expensive. If by any chance, it's unlikely but possible that the number of nodes on the network could drop below the minimum required to maintain consensus. And if that does happen, the network can then cause itself to shut down intentionally. In this case, all of the assets on the network are returned to their owners. THORChain has mechanisms to help the network, to help the system grow as the network does. So a committee oversees the primary vault, which holds the network's Rune, and this committee can only grow so big before the threshold signature scheme gets too slow. Once the key generation process begins to take too long, the primary vault is split in two. This process repeats until the network hits either the block consensus limit or the economic limit, and we'll describe both now. So the block consensus limit, when the THORChain blockchain, given that it's based on the Tendermint consensus, bear that in mind, so large committees slow down the processing of transactions onto the network's blockchain. The target speed for creating new blocks is 5 seconds, and when the block speeds get too slow, slower than 5 seconds, the system lowers the rewards that nodes get per block. The thinking here is that this should reduce the number of nodes as they have less incentive to participate. In terms of the economic limit, there are only so many nodes who can really participate on the network, and this is because there's a minimum bond amount and a fixed supply of Rune. So that should keep the number of nodes participating in check, but if it doesn't, the number of nodes can also be kept down through governance. So the THORChain network needs to take care of assets from connected chains. This is tricky because all these assets have fluctuating prices, prices that are set by the free market. So Rune is the main asset which secures the network, and so the value of Rune needs to be tied to the value of the assets from connected chains. What's more, the amount of Rune that nodes need to bond needs to always be higher than that which can be gained from stealing the assets. The value of connected assets is always tied to the value of Rune, and the exchange formula, which we talked about earlier, makes sure of this. If the amount that nodes have bonded in Rune is double the amount that has been staked in pools, then the staked capital is safe. The network is made even more safe by the fact that Rune is really only useful and valuable if the THORChain network is actually working. If the network is down and you've got a bunch of Rune, if the network's down because you stole a bunch of Rune, then it's not very useful or valuable because the THORChain network will no longer be functioning. So given all this, to make sure the network's safe, THORChain gives rewards to keep the optimal balance of nodes and stakers. And that balance is 67% of Rune being bonded by nodes and 33% of it being staked by liquidity providers. Sometimes this split will become unbalanced, and so to fix this, the system has something called an incentive pendulum. If staking is low, the rewards for staking go up, and if the split is correct, then there are no staking rewards. So this mechanism keeps the network balanced and secure. All active bonded nodes get a reward each time a block is processed. The system tries to keep the amount of Rune that nodes need to be pretty stable. Over time, this increases the median bonded amount, and that in turn increases the network security. To stabilize the bonding amount, the system gives the same amount of rewards to each node. So it's not that if you bond more that you get more rewards. All nodes get the same amount of Rune as rewards. Doesn't matter, really doesn't matter how much you bond. So nodes just need to bond enough to get chosen to become active in the next cycle. So as mentioned, the system also punishes bad behavior in nodes, doesn't only reward them. This is done to keep the level of service for end users high. So nodes are punished when they do several things. Firstly, when they fail to make witness transactions. Secondly, when they fail to complete key generation, which is equivalent to creating vaults, primary and secondary vaults, and completing key signing. So if they abort or fail to complete a key signing, which is involved with sending outgoing transactions, then they also get punished. And the actual mechanism by which they get punished, we described earlier, happens through slash points. So they build up slash points when they're active on the network, and when they get cycled out, they get the number of rewards they're owed minus the number of slash points they've got. So in terms of incentives for liquidity providers are rewarded for keeping their assets in the network's pools, and they're also rewarded every block. They're rewarded every block, but they actually only receive the rewards when they pull their funds out of the liquidity pool. The rewards are calculated according to whether or not the block contains any trades. So if it does, then the amount of slip-based fees, as we described earlier, sets the amount of rewards. If the block doesn't contain any trades, on the other hand, then the amount of assets in the pool determines the rewards. So liquidity rewards make up 1/3 of all what's known as system income. System income is the total value of fees in each block. So that's not just to liquidity providers, but to nodes to the network. If the total value from slip-based fees makes up more than 1/3 of the system income, so it's higher than 1/3 of the system income, that extra capital goes to nodes as a reward. And this means that if only a few assets are being removed, nodes can still get paid. On top of the slip-based fees, a network fee is taken whenever assets are taken out of the pool, and these are placed into the network's reserve. the reserve will be used much further down the line when block rewards run out and nodes need to continue to be rewarded. Governance. So THORChain has some principles of governance, and in essence the system aims to have as little governance as possible baked into it. And this is done in large part to avoid collusion, where groups of nodes work together in order to gain control over the network. So where other networks and protocols have the ability for nodes to directly communicate with one another and know who the other nodes are, this doesn't exist in THORChain, and that's, as I say, important to avoid nodes coming together to take control. So you might wonder how are assets, how is it decided that assets get listed and delisted, and the same for chains. How is it decided that chains get listed and delisted? Also protocol upgrades, how does that mechanism work in this situation where there's very little formal governance? So in terms of asset listing and delisting, the main form of governance is done when users signal to the network which assets they want to have available on the network. And to do that, they make a staking transaction into the network. Basically, they put some of their assets in. So say ERC20 tokens are now supported on THORChain, but the Aragon network token is not supported yet. What you would do as a liquidity provider would be to make a transaction into the network with some Aragon network token, and that would then be processed. So THORChain, in order to process that Aragon network token, would firstly disable it by adding it to what's called a bootstrapping pool. And so this is basically a normal pool, except for the fact that swapping is disabled on it. And then every few days, the network will look at all of the bootstrapping pools which are available, and it will list the one with the highest value. So that's basically how assets get listed on the network. It's very low governance. It's purely a function of how much the community wants those assets listed. To delist the assets, that happens when all liquidity providers have taken their assets out of a pool, basically. So with the Aragon network token, if everybody removed, all of the liquidity providers removed their assets from that pool, then that asset would be delisted. And then if somebody later decided, once the ANT had been, Aragon network token had been delisted, that they wanted to relist it, they would just follow the same process again, and then they could get it relisted. So that's assets. Chains work a little bit differently. So if you want to get a chain listed or delisted, it's more of an effort, because if you want to support a new chain, an entire new code base needs to be written in order to support it, to translate witness transactions, to translate outgoing transactions, and a whole bunch of other logic which needs to be in place specifically for that new chain. So when the community wants to support a new chain, developers can write software which connects it to the THORChain, and that gets submitted to a core group of developers who test and validate it. If it gets accepted, it gets added to the main piece of software called the primary binary, which all nodes run. And you'll remember that when nodes are cycled off the network, they have to update their software. And this is great because it means that chains and other new additions can be added to the software regularly. So in practice, when 67% of nodes have cycled out and are running the new piece of software, then supporting a new chain, then in essence that chain is then added to the network. To delist the chain, nodes just stop watching it, and when 67% are no longer watching, it gets removed. And then a process begins where all of the assets for that chain are returned to their original owners. In terms of protocol upgrades, a slightly different segment of governance, there are three main components to the software that nodes run and which potentially need to be upgraded. There's the application logic, which is involved with running the blockchain. There's the schema, which stores key values of vaults. And there's the network software, which keeps the threshold signature scheme, protocol key generation, and signing in check. So upgrading the software actually happens, as mentioned, when nodes are cycled off the network. So the application logic and the schema have versions, and when the node wants to re-enter the system, they need to say which version they're running, and they're only permitted if they're running software that's more up to date than 67% of the active nodes on the network. And so that over time increases the version of the software which is running on the network. When upgrading the network software, so we just talked about application logic and schema, but when upgrading the actual network software itself, the first thing that happens in order to upgrade that is that the nodes will agree on a certain block height in the future when the upgrade will happen, so a certain point in the future when the upgrade will happen. And then when the network reaches that point, the whole chain stops. There's a Genesis import to a new network, and it's off. So that's protocol upgrades. In conclusion, THORChain makes exchange of assets possible across a wide range of blockchains. It's secured by economic rewards and punishment, and the nodes who run the network are regularly cycled out and need to reapply, which keeps the network service resilient and available. And in terms of external assets, they're pooled and can be swapped easily.